Hi everyone, I'm Tomasz Knopik from NVIDIA. I'm here to talk about AIStore, specifically about its ETL feature, known as Extract Transform Load. In this video, I want to give a brief introduction into the ETL feature. Then we'll jump right into a quick tutorial on transforming ImageNet dataset. AISetl gives the ability to run user-defined workloads on the storage cluster. It allows users to offload computation from a training machine, such as NVIDIA DGX station, to IO-optimized nodes. Computation is done on the same physical machine as the object is on, maximizing the overall performance. This tutorial will guide you how to download ImageNet dataset to AIStore cluster. Then write a transformation function, apply the function to each object in dataset remotely on the AIStore cluster, and eventually get the transform objects from the AIStore. However, this tutorial is not about deployment of the AIStore. To get more information on this topic, please refer to our other videos and documentation. Links to those are in the description of this video. There are two requirements before starting this tutorial. First of all, AIStore cluster deployed on the Kubernetes. This is the primary requirement of ETL feature. The last one, a Jupyter Notebook with access to Kubernetes cluster network. Okay, so let's begin. First of all, let's check if our cluster is running with AIS show cluster command. As you can see, our cluster has 3 proxies and 3 targets. Next, let's list all running ETLs with AISetl ls command. As you can see, there are no ETLs running. Notice that if AISetl ls command returns any error, your cluster is not ready for ETL. It's not the case here, so we're good to continue. We should now create a source bucket in which we will store a dataset. Let's download the dataset from web directly to the AIStore cluster with download command. We'll use AIS start download command with brace expansion syntax. It will download exactly 10 tar archives, each 1 GB large. We should wait until the downloading is complete. After it's done, we're good to check the contents of the source bucket. There are exactly as many files as expected. Let's see what's inside of the downloaded tar archives. The archives have both JPEG images files and JSON metadata files. Let's display the first image from the first tar. This image, along with others inside of archives, will be transformed in the next section of this tutorial. The easiest way to initialize the ETL is with AISetl build command. According to the documentation, it requires transform function, which simply takes bytes and returns bytes. In our case, this function will transform tar archives. First of all, let's download the dependencies with pip install. Once it's done, we can jump into writing our function. First of all, import the required dependencies. In our case, those are Torch and Torch Vision, used to transform images. Image2bytes function is a function which will help us to get image bytes in JPEG representation. It will be used in the next part of this script. Next, we declare transformations. Those will be applied to each image in the tar archive, and eventually to each image in our 10 GB large dataset. We are now ready to define transform function. As mentioned earlier, it takes bytes and returns bytes. First, it opens the tar file from input bytes. Then it creates output tar. For each member of the input tar, it selects only those which are JPEGs. Then it limits the number of processed images up to 100. For each image, it opens it, then it applies the transformation to the image, Then it adds the image to output tar. Eventually it closes the output tar and returns the bytes. Let's verify that it works correctly by running this transformation locally on a single archive. As you can see, no errors means we're good to go. Let's come back for a second to the script and add the magic command. It will save the function to the file name code.py. Right now, we have to define dependencies which our script uses. It's the same format which all requirements for pip command are defined. We are ready to initialize our ETL now. We use AIStore build command. It takes 3 additional arguments: file of the script, code.py, dependencies file, and runtime type. The runtime in our case is Python 3, however Python 2 is available as well. Let's wait for the operation to complete. Okay, so our ETL is ready. The build command returned the UUID of our ETL. It will be used to reference our ETL from this point. Now we can finally start transforming our dataset. We can do it with AISetl bucket command, which takes UUID of the ETL, source, and destination bucket. If the destination bucket does not exist, it will create it. Note that this command works with cloud buckets, allowing you to transform objects stored in the cloud. We should wait for the process to finish with wait command. Then we can list the content of the destination bucket. Okay, so the operation has completed. As expected, destination bucket has the same number of objects as the source bucket. Note that this operation transformed 10 GB of data, all done on remote AIStore cluster. Let's see the archives after the transformation. As you can see, the JSON metadata files are filtered out by the transformation, and there are only JPEG images. Right now, we are extracting the single image, the same one which we saw at the beginning. As you can see, the image is cropped. To stop the ETL, which we created in this tutorial, we have to use AISetl stop command. It needs the UUID of the ETL. The command has stopped all ETL containers and freed the resources. This concludes this tutorial. For more information about ETL and AIStore, see the links in the description. Thanks for watching, hope you enjoyed. Goodbye.